I think a great tool here is the graphing calculator. So I'm going to pull it out. You know, I'm going to go to the y equals screen. And I'm just going to graph what I see here for the parabola. X squared plus 2x minus 3. I'm about to graph it. But let me just say something about it. I'm interested in where is the output of this function bigger than or equal to 0. You guys see that? So if I hit graph, I can actually see it. I can see that over here, we have a place where it equals 0. You guys see that? And over here, we have a place where it equals 0. Those are called the zeros, or the x-intercepts. And between there is no good. Between there, we're below 0. But basically, on either side, things are good. You guys with me? Now, that's nice. But I want to show you a technique that we're going to use again and again and again in this class and in other classes, continue to take math classes here at Lakeland. And it's called a sign diagram. Okay? A sign diagram. And what I do is I have a function. In this case, f of x is x squared plus 2x minus 3. Right? And I draw a number line, kind of like I did for absolute value. And I want to know, well, where is this function greater than or equal to 0? Because that's what the problem says. So the first thing you do is, let's start by plotting the zeros. And that's easy for this problem. It's not easy for all problems. Sometimes you need to use the quadratic formula to figure out what the zeros are. But this one's easy because how can I rewrite f of x? Do you see it? It'd be x plus 3 and x what? Minus 1. So the zeros would be negative 3 and positive 1. And actually, we see that if I turn the calculator back on. You can see that at negative 3 we have a 0, and at positive 1 we have a 0. So that's kind of nice. Here's 0. Here's positive 1, and here's negative 3. And since you're allowed to equal 0, those are solutions. Okay? You guys with me? And then what you do is, so we start by plotting the zeros. Then, in each interval, we pick what's called a test point. Okay? So, for example, give me a number between negative 3 and positive 1. Well, negative 2 would work, right? Negative 2 would work. Actually, we're going to need 2 also. Because we're going to need 2 over here, okay? So I'll tell you what I'm going to do. I'm going to pick f of 2, and I'm going to test over here. Now, what's f of 2? Well, let's use this form here. That works pretty nice. It's 5 times 1. You guys see that? Which means it is 5. That's positive, right? That's what's really important. It's bigger than 0. It's positive. You guys with me? So do we want to include that as a solution? Yeah, it's bigger than 0. You guys see that? So since once I know 2 is a solution, I claim that everything over here has to be a solution. Now, how do I know that? Well, because quadratic functions are continuous, right? And so on the picture, if this is above 0, can ever get below 0 is if somewhere it hits 0. And that's why you only need to test one point in each interval. You guys follow? Ryan mentioned we could try -2. I'm going to try 0. That's my favorite test point. I always use 0 because it's so simple. Look, what is f of 0? Well, it's 3 times -1, which is? All I care about is that it's negative. If it's negative, that means there aren't any solutions in here. Because once one of them is negative, everything between there and there has to be negative. You just test one point for the interval. Here, you guys try any point you want for the left-hand side. Decide if it shows up negative or positive. Let me just do the last one. Suppose you pick a point to the left of -3, like -10,000. Not that that's a smart choice, but it works. So what's f of -10,000? Well, I don't know. All I know is that when I add 3 to it, it's negative. And when I subtract 1 from it, it's negative. See how I'm not even figuring out what it is. All I care is negative times negative. So what's it going to be? You see that? So f of -10,000 is a solution. Actually, all these points on this side of -3 are solutions. And so the graph of number 17 would be this. And again, we could write the solution in interval notation. We could say -∞ to -3 with a bracket, union 1 to infinity. You guys follow? Okay. So, I'm going to do one more thing here, but it's actually chapter 3, and then we're going to close down.
Yeah, to help you through these, we're going to need to do extra examples on Monday. That's all there is to it. All right, so I have the inequality is 1 is less than absolute value of 2x minus 9, and that's less than or equal to 3. Okay. So, again, what I want to do is I want to scratch that. Let's do 28. 28 says x squared is less than or equal to absolute value of 4x minus 3. Okay. Now, I claim that this is really two problems. Sometimes this problem looks like this. X squared is less than or equal to 4x minus 3. Other times this problem looks like x squared is less than or equal to 4x minus 3 in parentheses with what in front? A negative sign. And the question is, how do you know which case you're in? Well, what we have to do is we have to figure out when is it that 4x minus 3 is greater than 0. Let's say greater than or equal to 0. Give me a second. Okay, I'll try to explain. I'm taking away the bars. It either equals this or this with a negative. Okay? And it comes down to this inequality. 4x minus 3 is greater than or equal to 0. By the way, we can make that 4x is greater than or equal to 3, so x is greater than or equal to what? Okay, so I guess what I'm saying is, if x is bigger than or equal to 3/4, we are over here. If x is less than 3/4, I need to put a negative sign in front. So let me go through and kind of give you the two cases. This one is x squared is less than or equal to 4x minus 3. I'm fine with that. This one would be x squared is less than or equal to negative 4x, and then what? Positive 3. Okay? And the question is, how do you solve this? How do you figure out an inequality like this? Well, the first step is you set it equal to 0 in a sense. What we're going to solve instead is x squared plus 4x minus 3. And we ask ourselves, when is that less than or equal to 0? Okay? And I'm out of time now, so I'll have to come back to this discussion on Monday. But maybe this hint will give you guys what you need. I don't know. We'll review Chapter 1 on Monday. We'll review Chapter 2 on Tuesday. You guys have a good weekend. Oh, I'll take it if you want it. If you want to hang on to it, that's fine too. But if you want to give me homework, throw it there.